Use the definition of tangent to explain why y equals tan x has vertical asymptotes at x equals 2k, basketball, minus 1 pi all over 2 for any integer k. Well, what is the definition of tangent? Well, tangent x is the same as sine x over cos x. Now, vertical asymptotes exists when the denominator is equal to 0 as long as the numerator is not equal to 0. So we have to take a look at both of these. So let's take a look at both of these. Let's label sine in red, and let's graph what sine looks like generally speaking. Okay? Keep this very simple. Sine starts right here, peaks out at 1, bottoms out at -1. It comes up here at half a pi, and then hits the x-axis at pi, comes back down, hits the x-axis at 2 pi, goes back up, hits the x-axis at 3 pi, and looks something like this. Now, why is this important? Because x is 0 at 0, and pi, and 2 pi, and 3 pi, and stuff like that. That's for sine. Now, if you're like, if we only care about cos x, why are we doing sine? I don't know, just in case there's holes or anything like that. There won't be, but I had fun doing this anyway. Let's do cosine in green, my favorite color. And so let's quick graph what cosine looks like and see where we cross the x-axis there. Cosine starts at 1, bottoms out at -1. So if it starts at 1 and bottoms out at -1, it crosses the x-axis at pi over 2. Then it bottoms out at pi and crosses the x-axis at 3 pi over 2. Then peaks out at 2 pi and then hits the x-axis again at 5 pi over 2, and so on and so forth. Okay, so my zeros here are pi over 2, 3 pi over 2. Since this is periodic and it's going to keep this process, you will notice that there's no overlap between these numbers and these numbers. So cosine hits the x-axis, or in other words, is 0 at stuff like pi over 2, 3 pi over 2, 5 pi over 2. Well, how do I write that out as a general equation? Well, we would say something like pi over 2. And if I needed to, include 3 pi over 2 and 5 pi over 2, basically I want to multiply this guy by every single other number, every odd number. How do I write out an every odd number? 2k minus 1 gives me every odd number. So again, if I were to plug in like 1, I would get 2 times 1. 1 minus 1 is 1. So 1 pi over 2, like you. And if I were to plug in 2, then I would get 2 times 2 is 4. 4 minus 1 is 3. 3 pi over 2, so on and so forth. That, when simplified, and that when multiplied to the very top, gives you x equals 2k minus 1 pi all over 2. And so since vertical asymptotes occur when the x values of the denominator equal 0, as long as it doesn't do the same thing for the numerator, these guys are the equation, or is the general equation for the vertical asymptotes of tangent, as long as it's just regular tangent. When it's not regular tangent, it complicates things. But that is how we use the definition of tangent to come up with the vertical asymptotes in that form right there. Fun!